I'm going to go over some of the elements of CMake basis that are described in the Quick Start Guide. To see the Quick Start Guide, just go to the basis main page and click on Quick Start. Now this is the Quick Start Guide, but there's also a shortcut to follow the steps in the Quick Start Guide. If you go to the repository external link, the example directory, and quickstart.sh, you can save the quickstart.sh file, which will run the Quick Start for you. So I'll check that it's here and run it. While that's downloading, I'll open the file and explain what's there. First of all, this file clones basis into the local directory using git. Then it uses CMake to create a build directory, build basis, and install it into a locally specified directory. So this -g is the generator. If you don't leave this line, it'll use the default that CMake has for your system. Otherwise, it'll use Ninja if you've got it. So in my case, it would be the equivalent of specifying Ninja like that. And the reason you would want to use Ninja is because it's an actually noticeably faster build system than Make. Now it's just finished running, and we are up to creating a basis project. But first, the script also sets a few variables that puts the basis project command on your path, links you into the example directory, and gives you quick access to the basis example files. So to show you those, we'll go over to this directory. Basis Quick Start was just created. In bin, basis project is the main executable. In source, this is basis itself. And in the example folder, there's these files. That's what's being added to the path. And the resource directory is hello basis in the example directory right here. So next up, we run the basis project create command. This is used to create a new project. As you can see over here, the files for the project are added automatically by basis. And let's go over the parameters. You give it a name, hello basis, a description explaining what your library will do, or executable program, and the root directory, which is where you want it to be created. Then we want to actually add an executable to run. So we go into the hello basis directory, copy out of the resource directory with some pre-made files to make this quick start easier. We copy hello C++ into the source folder. Then we add the executable creation function into the CMake list.txt. Now, if you're experienced with CMake, you might notice that we have basis add executable instead of simply add executable. The reason we do this is because basis takes the information you provide to automate a ton of other steps, including creating installers, creating uninstallers, exporting variables for other CMake utilities to use, and some other steps as well. So let's go have a quick look at that file. If we go into hello basis source, we have the CMake lists. You can see basis add executable is here, and a little bit later on we're going to do add library. So at this step we're adding a private library. we go to the directory, copy the foo library files, that's a C++ and a header file, and we call basis add library. This creates a library with the name foo using the file foo.cxx. And we added that into the CMake list.txt, which you can see here. Then we add a public library. This is one that users are actually going to include. So the header files will be available. So we make an include /hello basis directory because we want users to do #include hello basis / something rather than just #include bar.h, for example. You want to namespace things. That's very important. Then we call basis add library, which is just like the CMake add library, but it helps automate a lot of other steps. And we add that to the CMake list.txt. And in this case, we copy bar.h into the include directory that we created, and the bar.cxx into the source directory. Then we compile the hello basis module. We create a build directory in the hello basis folder. Then we go into it and compile the utility and install it. Also note the CMake install prefix. That's the directory to which everything is going to be installed. This sets a flag specifying if we're going to build the documentation. So that's the first initial steps in the quick start. Let's have a look at what we created. So here we're in hello basis. This is the build directory with the executables in it. Then we've got a documentation directory, the include directory with hello basis and bar.h, the source directory with all of the relevant files, and an empty test directory. You might also notice that we've created a few extra folders here, or files here. There's a README, installation instructions, and two other important files, basis bootstrapping and basis project. Basis bootstrapping you actually don't really have to worry about. What that does, if you try to build your library on a system that doesn't have basis at all, it'll automatically download and locally install basis in your system's build directory so that your program will still build. Now, basisproject.cmake is a very important file. This specifies all the metadata about your project, including its name, version, who the authors are, the description string we specified with the basis project command, as well as other general information that's frequently needed in a library. So now that we've got our basic library and know how to create one, we can move on to the next important component, which is a top-level project. One important design element of Basis is it lets you merge multiple components together easily and add them or remove them as you need. And that's what a top-level project is for. So one project can contain two other projects that are each relatively independent. And by combining them all together with the top level, you have a good way to split and reuse your components and your libraries. So here's how that was created. Again, we're using basis project create. This time we're naming it hello top level, giving it a description, and specifying the root directory. The main difference here is the -- top level. That tells it that it's going to create a top level project, and in particular also create the modules directory. Then we need to create the two sub-projects. We're going to call them Module A and Module B. So the module A directory is going to be in hello top level modules module A. Again, we use the same basis project create, name it, description. This time though, we're creating a module. And this module is going to need an include directory because here we're creating a library which is going to be used by another module. So we copy the library CPP file, create the directory, and create the module header. So in this case, if we go to the modules, go to module A, in our include, we have hello top level and module A.h, and in our source, we have module A.cxx. These modules can either be considered to be part of the top level project, so it's just all one big package, or alternately, they can be smaller components that are independent of each other. In that case, you wouldn't want to call this hello top level, you'd want to call it mod A, or whatever the name of your project is. And here we also have another basis project and a CMake lists. So let's move on. We've created that. Now we need module B, which is going to use module A. Again, we're using basis project create. Name, description, root directory, and this time it's a module. It's going to have a source directory, and here's the key. We're using module A. This will simply goes to the basis project.cmake line and adds this bit, depends module A. That means that module B will look for and include the directories of module A. So now we need to create our executable that actually uses module A. So we've copied the files in, and right up here, and we're calling basis add executable and basis target link libraries. This means that once we build module A, we're linking it to the user program. And then we're placing all of that into the CMake list.txt. Finally, we've got our whole hello top level project created, so we're going to build it. We go to the top level directory, create it, the build directory, go into it, and then do the same exact build process as we did for basis itself. The generator again could be make, or it could be Ninja, or you can just leave it out and that'll be the default of your system. The install prefix, where we want it to install, and the install scheme, which is what layout we want the files to install with. And finally, we install our tool. Now, if we go to the main basis quick start directory, this is what's set as the local directory. We can look in here. We've got, again, basis project. We've got the hello C++ and the user pro. If we go into lib, we can see that we've got the module A library there. And then in the documentation, we have the automatically generated documentation if we had enabled it. Right now it's not enabled. but we do have the copying. And that's it for the Quick Start guide. Again, you can go to the Basis site and see the Quick Start instructions and follow them yourself. They're very easy to follow and clear. And you can go browse the site for instructions on how to do different common tasks, the standards on how Basis is set up, a reference on how exactly Basis works and what the files are created, and API documentation of Basis libraries, both for CMake and C++, Python, Perl, Bash utilities. And that's it. Goodbye.